Welcome everybody to today's webinar, Continuous Monitoring Using Advanced Statistical Analysis. My name is Jim Kaplan. I'm founder and owner of AuditNet, and I will be moderating this webinar. Joining us is Richard Cascarino, Principal of Cascarino and Associates. Let me have Richard introduce himself and give a brief overview of his background, and then I'll cover some of the housekeeping items for this webinar. And there are slides in here both for AuditNet and for myself. You can take a moment to review those. Richard, if you would just introduce yourself, please.
Surely. My name is Richard Cascarino. I'm the Principal of Richard Cascarino and Associates. We're based in Colorado and in Johannesburg in South Africa. My background is over 30 years experience in IT audit training and consultancy. I'm a past president of the Institute of Internal Auditors in South Africa. A member of the Association of Certified Fraud Examiners, and of particular relevance to this webinar, author of the Auditor's Guide to IT Auditing. That's my background. For those of you who logged in to hear this previously, I must apologize that I had been bitten by a tick and ended up with Lyme disease. So I appear to be recovered now. If I occasionally cough, please accept my apologies. Let me hand you back to Jim for some of the housekeeping.
Thank you, Richard. Let me cover some of the housekeeping items for today's webinar. This webinar and its material are the property of AuditNet and its webinar partners. Unauthorized usage or recording of this webinar or any of its material is strictly forbidden. We will be recording the webinar, and if you paid the registration fee, you will be provided access to that recording within 2 business days after the webinar. Downloading or otherwise duplicating the webinar recording is expressly prohibited. We kindly request that everyone fill out the brief online evaluation questions that you will see at the conclusion of the webinar. Your feedback is very valuable, so please take a minute or two to complete the survey. In addition, because this webinar qualifies for CPE credits, we will be putting up polling questions in compliance with NASB rules. Those answering the questions will receive their CPE certificate by email within 7 to 10 business days. You will have an opportunity to, both during and at the end of the webinar, to ask questions. Submit your questions during the presentation via the chat window at the lower right-hand box on your screen. Type your question and press return to send it. Any question we're unable to answer by the end of the webinar will be answered via email directly within 48 hours. As moderator, I will be launching the polls, showing the results, and monitoring any questions. And also, if GoToWebinar stops working, you may need to close it and restart the application. You can always dial in and listen and follow along with the handout if you paid the registration fee. So please join me in welcoming Richard Cascarino. And Richard, I'll now turn the floor over to you to cover today's topic, continuous monitoring using advanced statistical analysis. Richard?
Okay, thanks, Jim. As Jim said, the agenda for today is to look at the concept of using advanced statistical analysis techniques in starting to implement continuous monitoring. And we're going to do it in twofold. We're going to do part of it which is hands-on, and we're going to look at systematic sampling, random sampling, stratified random sampling, monetary unit sampling, classical sampling, and then moving into the advanced side, looking at correlation analysis, trend analysis, and time series analysis as specific techniques. We'll then look at the use of them within a continuous monitoring environment. And this will then lead to the next seminar, which will be a webinar rather, which will be running, which is on script writing, which then takes and builds on this into building continuous monitoring techniques within the systems. Okay, so in order to get started, let me kick off by moving out of the slides, and we'll go into a hands-on using idea. So I'm in idea. Hopefully you can see that on the screen. And what we're going to do is start off by having a look at the way that we actually carry out sampling. And what I'm going to do is I'm going to use the import assistant, which hopefully you're all familiar with, to import to IDEA a file called customer database. So it's going to come in as and it's going to come in from the tutorial directory. And I import that, tell me which database, length, how many I want that's take. The first 10 is less than records in the database. And you can see at the bottom, show the number of records, number, the first name, country. Okay, I'm going to do some sampling on the first step is to do some systematic sampling. So up on the top on the menu bar we'll go into sampling, and this is probably the most simple form of sampling that I actually carry out. So I'm going to do sampling with a selection interval of initially setting my selection interval to 10, and it's going to say compute. I now need to look at 35 records, which when you think about it makes sense. If I'm going to look at every 10th record out of 341 records, I'm going to end up with 31 records. Now that's straightforward sampling, but it's not necessarily statistically valid sampling. To make it statistically valid, we've got to come up with a random number to start our selection process. And in this case, I'm going to use a starting number of 7. And when I do that, if I then go in and do my selection, again it's saying selection interval 10, number of records 35, starting 7, the ending record is the last one I have, 341. And if I now say I'm going to take that, say OK, it's now done my selection. Okay, so it's selected me 35 records, starting with a random number that I chose as being 7, and then taking every 10th one from there. Okay, and that should give me a straightforward selection. I'm getting a message saying my audio is breaking up. I will apologize. I will try and keep it as accurate. I'm getting a message saying the sound quality is poor, sounds like a robot. Oh, that's because I'm speaking in Robotnik. So I apologize if we're having problems. If this continues with problems from here, I'm actually moving to a new location on Monday, which will give me approximately 10 times the bandwidth. So let's see if we can carry on using it at the moment, failing which we'll have to make a plan. Okay, so hopefully we've all had the opportunity and we now can see our selection, our systematic selection. Now that makes sense from a sampling perspective if you have a randomly set up population. If the population is not randomly set up, then using systematic selection can cause you problems. If I go back to my customer database, you can see that we started off with 5 records from South Africa. Now I said I want to start with the 7th record and then take every 10th record from there on. So right away I've jumped over all of South Africa. I've eliminated them from the selection. So that may not be the ideal way to handle it. So rather than straightforward systematic sampling, I can use other sampling techniques. For example, stratified sampling or random sampling. I could end up with a different selection. If I go to random, again I'm going to start with my 35 records. My 35 records. It's looking for a random number seed. It's generated automatically. I'm going to start somewhere between 1 and finish at 341. I have a choice. I can allow duplicate records or not allow duplicate records. Now, allowing duplicate will allow the same record to be selected more than once. And this is appropriate if you are doing pure statistical sampling. If you're doing what auditors do, which is applied statistics, obviously you don't want to select the same item to check twice. So we use what's known as a degree of freedom of 1, and we will subtract 1 from the population every time. So we will not allow duplicate records. And if I say now, OK, I'm ending up with a totally different selection based on pure random selection. Okay, so we now have a random sample. Here we had the systematic sample, and you can see we started with customer 10101, then 10900 with a straightforward random. We started off with our 8th record at customer number 21163. Second one was 40732. So it's a completely different selection. Okay. Another alternative would be to go for a stratified random selection. Now, right now, the database I'm using, my customer database, has not been stratified. So the first thing I have to do is stratify the database. And I'm going to perform a numeric stratification. Statistics are not available. Do I wish to create statistics for all fields without it? Well, the only one that will create it for is the credit limit, but that's fine. So I'm going to stratify on credit limit, and I'm going to total on credit limit. And now you can see my increment is 10,000 from there. And again, I can carry on and drag that and give myself a strata. If I tell it OK, here's my stratification. There's my random seed number that's calculated itself. My number of records is going to be, as you can see, 0 in there. There's 213 records in there. There's 48 in there. Now, I've not selected any records to sample, so I've got to choose a sample size other than 0 in one or more of the stratification. So where my number of records are 0, I can then select the sample size. For example, I could select that I want 5 from that strata. Well, there's no records in there. But in here, I could say I want 21. Given the fact that I'm going to take 10, I'm going to take 5 out of there. I'm going to take 2 out of there. I'm going to take 1 out of there. I'm going to take 1 out of there. And I can go all the way down. And you can see I'm sitting with 30 records that I've selected. I could carry on till I've got my 35, or I can simply say OK. And it's now stratified it. But it's allowed me to select the number of records based on the size of the strata. So I was able to influence the record count while maintaining the statistical validity. Okay, are we happy? Those are two common types of auditing that auditors use within the normal processing. All we're doing at the moment is selecting records which we are then going to go on and test. Okay? That's all we're doing at the moment. We're simply picking the ones that we're then going to go on and test. The sampling will tell us which ones to test. It will not do the testing for us. What I might have to do now is go, for example, and take these selected items and check that that credit limit is in fact a valid credit limit for that particular customer in that particular country. And you can see there it tells me which strata it picked these ones out of, and I stratified it based on the credit limit. Okay, these are the sample record numbers that I picked. But I still have to now take these records and go and do my testing and then draw my conclusions based on those tests. And typically what I'm looking for with those is to sample a few to draw conclusions about many. That's why we're thinking. So that if we look at a small number, i.e. the sample, we can draw conclusions about the total population. And that's a valid way of auditing, because by doing it that way, we can specify how accurate we need to be and how confident that our sample is in fact truly representative. We can calculate the sample size in order to determine a specific level of confidence and a specific level of acceptable errors. Let me go back into the customer database again. And we'll go and sample. This time we're going to look at monetary unit sampling. Okay. Now monetary unit is slightly different. If you look at the fields that are held on there, we've got our credit limit of 4,000, 20,000, 12,000. When we look at monetary unit sampling, the unit that we are sampling based on is $1 or €1 or £1 whatever the currency is. And what that's doing is it says there are 4,000 units in that first credit limit. There are 20,000 units in that second credit limit. So I have 4,000 chances of picking up that one. I've got 20,000 chances of picking up that one. I've got 280,000 chances of picking up that one. Okay, so what it's doing is it's making the probability of an item being selected proportional to the size of the item while maintaining statistical validity. So if I put into my monetary unit and say, okay, I want to do my planning, it's going to say, well, what field am I going to use? I'm going to use my credit limit. I could use only the positive values, positive and negative values, or absolute values, which is all of the negative and positive added together. It's telling me there that my value of the total sampled population, at the moment we're looking at 100%, is 21,004,000. Okay? My setting right now, I'm looking at a confidence level of 90%. Now, auditors normally work at a confidence level of 95%. I'm looking at my amounts, my settings. On my amounts, I've got tolerable error and expected errors. I can do it by amount or I can do it by percentage. In this case, I'm going to do it by percentage. My tolerable error, heads will roll, I have been told by management, if the error is more than 5%. But we don't expect that 5% of our records are going to be wrong. We expect a maximum error rate of 1%. Okay? Now, with all of that, I can now say, go estimate how many I need to look at. And it tells me to draw conclusions at a 95% confidence level with a tolerable error of 5% and an expected error rate of 1%, I need to look at 90 items. I need to sample 90. out of my population. And my sampling interval this time is going to be that value of the sampled population divided by 90. So what it does is it takes into consideration the cumulative value of the population, in this case credit limit. Now adding up the credit limits is a meaningless number. It's a hash total. But it allows me to sample that sampling interval every 236,000th dollar of credit limit, which will automatically bias it towards high-level values. Now that's very useful to the auditor where you're looking for overvaluations, etc., or you're looking to select high-value items to then go and further examine. Where you're looking for undervaluations, this is not a good form of sampling. Because it's automatically biasing it towards high-value items, it's obviously automatically biasing it away from low-value items. So if something has got its value too low, this is like. Now what it tells me down here is I may accept the population at the 95% confidence level when no more than 90% total taintings are observed in a sample size of 90. Okay, so if I now say I will accept that, it's now telling me it's going to do a fixed interval selection, looking at high values, sampling interval, it's already calculated, it's got my random starting point, and it will then take every 236,000th credit value from that starting point. There's my positive values, there's my absolute value, there are no negatives involved in this, and I can say, okay, go ahead. And it's now done a sample, and what it's done, the monetary sample that's actually calculated, or selected I should say, shows me the customer number, the credit limit, the audit amount, it's showing me the record number, the total, and this is the total accumulative, and it's rolling forward from there. Okay, so it shows me which records, etc., that are picked out, and I've got, as you can see, is 26 out of 300 to get that number. Now the reason it's only giving me 20 is because the cumulative amount was allowing certain records to be selected multiple times, so that we could see, for example, that 181,000 may have been selected 2 or 3 times. It's only going to give me it once to check. It's biasing it towards the high value items. Okay. If I go back into my sampling and I start looking at how we can evaluate this, taking our single sample that we've got. Okay. We had our low value, we've got our 95% confidence level, that's the value of the sampled population, okay, and the sample size was 26. Now that's looking at low error rates, and what it's done is it's giving me all of the high value items in the file, so I can then go and check those individually. Now I can move from low error rates to high error rates, which is the class of sampling, or I can leave it down at low error rates. I can change my basic precision and pricing from 100%. When I'm happy with all of that, I can then say, okay, I've got to select a book value and an audited amount field for the high value. And I'm happy with those. For the high values, My book value field was that. My audited value was that. Because I'm saying that the high value items are not in the file, I can take that off. And what it's now showing me is my low error rate summary. So I'm working at my confidence level of 95%. My sampling interval was that. My basic precision pricing is 100%. And it's telling me there's my sample size. Overstatements and understatements, the number of errors was 0. Gross or most likely error was 0. Total precision, etc. Based on that sample then, the most likely overstatement in the population is 0%. Is 0. And the most likely understatement is 0. So we can infer with a confidence of 95% that the total overstatements in the population does not exceed that amount. And the total understatement does not exceed that amount. And I found 0 errors. That does not mean to say I have 100% certainty in the population. We selected that sampling interval, that sample size, in order to determine at a 95% confidence level whether value was within a certain area. And the only conclusion that we can make is that either is at a 95% confidence within that area, it does not exceed it, or we cannot conclude at a 95% confidence that it is or it is not. So where does this come in with continuous monitoring? This is the kind of test that we can set up using our scripts to continually monitor and sample from large populations to allow us to draw conclusions based on low quantities. Here we're looking at 26 records that we need to go and check. In fact, it's done the calculation for us. But the point being that if we are dealing with, let's say, 300,000-400,000 transactions a day, instead of waiting till the end of the day and then monitoring it and then selecting and sampling, we can set this up in a script to continually monitor and to continually sample and to highlight anything which is out with the ordinary, and which would then allow us at an acceptable time scale to go and check these items out. Again, if I take another form of sampling, I go back into my customer database, and we'll go into classical sampling. Again, I can go into preparation for classical sampling. I'm going to take off that automatic sampling of high-value items. I just want to look at all. I can go into my advanced settings. Within my advanced settings, I can tell it that the sample size, we know that we wanted it 35%, 35 items rather. Target number of errors is 0. Confidence level for minimum number of errors is 95%. Minimum sample size per strata is 10. If I tell it OK, then I say next, it's going to give me a histogram of the credit limit field showing the frequency over 2 strata. It's going to give me the mean, the book value standard deviation on the population size, and the boundaries. I can enlarge the chart to look at that in close-up or drop it back. Okay, happy so far. Good, because it's time for me to relax. And for you, for those of you who are registered, to do some work, because we've come to our first polling question. And as far as the polls are concerned, First polling question is asking the question, random sampling allows the auditor to A, select a beta risk, B, select a tolerable error, C, select a starting number, D, select an expected error. Which of these is true? If you go ahead and vote now. Okay. I'll give it a couple more seconds to allow everyone else to finish off. Okay, let me close the poll. And if we look at it, we're seeing that random sampling allows the auditor to select a starting number. We can look at the expected error, we can look at the tolerable error, but for random sampling, the whole point is to be able to select the starting number and choose at random. In pure random selection, random sampling, we're not interested in the error rates, tolerable errors or not tolerable errors. We're simply saying, go pick me numbers. Okay. Let me close that down. And let's move on and take a look at attribute sampling. So for attribute sampling, again, I'm going to stick with my customer database. But this time, I'm going to start looking at attribute sampling. There's two primary kinds of sampling that auditors use, attribute sampling and variable sampling. Attribute sampling is based on a dichotomous evaluation. It's either on time or it's late. It's right or it's wrong. It's the correct amount or it's not the correct amount. Variable sampling allows us to take variable, a value, a size, a weight, and then select based on that. So what we're going to do is we're going to start off, we know our relation size is 341 records. We have an expected deviation rate of 1%. We've got a a tolerable deviation rate of 5%. And we've got a confidence level to control beta risk of 95%. Now how do we know that? Because we can go in with our population size and plan our beta and our alpha control risks. So if we started off with a 341 and our confidence level to control our beta risk was 95%, which leaves us an alpha risk of 5%, with a total deviation, tolerable deviation of 5%, and a lower threshold, or expected deviation rate of 1%, we can then go ahead and compute. And what it's telling us, if we look at these, is if we do our selection, in this case, with those confidence levels and those deviations, it's come up with a sample size of 51. The number of deviations in the sample will be 0. Now what that's telling me is if I find 0 deviations within that sample, then I can be 95.01% confident that had there been something greater than 5%, I would have picked it up. So put it another way, if there are no more than 0 deviations in a sample size of 51, I can be at least 95% confident. It can't tell me how much I can be, it can only tell me at least, because that's where I started from. That the population deviation rate is not more than 5%. If the population deviation rate is 1% or smaller, you can be at least 5% confident that you will not observe more than 0 deviations in the sample. Okay. If I go back to look purely at the beta, and I compute in there, you can see in there it says 0 if I find 0 deviations in a sample size of 80. So if I want to control alpha and beta risk, I'm going to end up with a sample size of 51. If I'm looking to control just the beta risk, rather, the risk that the sample that I select will not be representative, I need to look at a bigger sample. I need to look at 80%, 80 items. If I find 0, I can be 99.3% sure that the error rate is 5% or less. If I find 1 error out of the 80, I can still be 95.14% sure that the error rate in the population is 5% or less. If I find 2 errors, you can see the percentage deviation in the sample is sitting at 2.5%. But in the population, I can only be 83% sure that the error rate in the population is 5% or less. And that's below my level of criticality. So therefore, I cannot accept that as an auditor, and I'm going to reject that population based on the sample. Now, what that would normally mean is if this was happening as part of continuous monitoring, I'm going to set off alarm bells and say there's something going wrong. We've exceeded the threshold level at our desired confidence. Management, get in there, find out what's going on, what's going wrong. From a continuous monitoring perspective. From a continuous auditing perspective, I now need to go in as an auditor to find out what happened within the control structures which allowed that confidence level to drop so low because we found so many errors within our sample that leads us to the conclusion that the error rate population could be higher than 5%. In the same way I can do my sample evaluation, I can put in my 341 of a sample population size. We found 3 errors in the sample. The sample size was 80, and our desired confidence level was 95%. And what it's telling me is it could be that the error rate could be as high as 8.5% in the population. In the sample, 3.75%, but not in the population. For an observed number of 3 deviations in the sample size of 80, we could be 95% confident that the population deviation rate is no more than 8.5%. Or put it another way, I can be 95% confident that the population deviation rate is somewhere between 1% and 9.68%. But again, I am not where I need to be at 5% or less. We have a problem. Okay. Let me close those down. What we're going to do now is take a look at some of the more advanced types of statistical analysis. So I'm going to close down these files. And I'm going to go in now through my import assistant to pick up an Excel, and the Excel spreadsheet is going to be called country emissions. And what I'm looking for is carbon emissions. So I'm picking that one up. The first row will be the field names. So there's all the country emissions year by year from 1985 through to 2004. Okay. I'm also going to go in and pick up on my import assistant, also from Excel, but the file I'm now looking for is one called Total World Emissions. Again, the first row is the field names. So now I can see country by country, year by year, the carbon emissions. And for the world, I can see year by year the carbon emissions. So what I want to do now is I want to look at what percentage of the total is Albania's for the year 1985. So I want to relate those two, and they're in two separate files. So the first thing I'm going to have to do is join the two files. Now, as we noted when we did the webinar on linking files, we've got a choice. We can make that country emissions the primary file, or the world total emissions the primary file. If I choose the world total emissions and then link the country emissions to that, I'm going to end up with 20 records. That's it, because that's my primary file. So I need to go to the detail file, which is my country emissions. And I'm going to go into my file and say I want to join two different databases. Okay. Primary database is my country emissions. There's 1,200 records. I'm going to pick up all of the records in the primary file, and I want to join it to a secondary database. And the secondary database is going to be, beg your pardon, the secondary database is going to be my world total with 20 records on it. I'm going to join it. I'm going to match where the primary key is the country, is the year. When the year on that matches the year on that, I want to pick up the countries in my primary file. And I can now see that from that one, there's country Albania, year 85, that was the carbon, and that was the file. Okay, so that's a year one total for the country, for the world, and that's the percentage of it, or not the percentage, that's the amount for each one of those countries for 1985. Okay, I can sort that by country. It's sorted at the moment by year. I can sort it by country, and there's country for each year. You can see I'm getting hashes because that field is too big. So I stretch it and it's happy. And we're now sitting with a joined file. I could change that and rename that file to emissions, or I can then go in on my analysis and go into advanced statistical methods, because now I want to go and do some correlation. And the fields I want to call by carbon. So I'm going to take the carbon. If I move that across, we're going to look at the carbon for Albania versus the total to see if there is a correlation year by year for that particular country. The audit unit field is going to be by country. And I want to include all audit units. So I'm going to pick up every single country. I'm going to create a database called correlation. What's that? So what it's now showing me for each of these is the correlation. I can go and I can say, show me it by graph. And there I'm getting the correlation for each one across all the different countries, from the lowest to the highest. And I can look down here and I can see that if I wish to look at the fields within that, I can see exactly what is being correlated, which countries are correlating most with their information. So if I go back into my slide, interpretation, we're seeing there that the world's total emissions show a steady increase on the period 1985 to 2004. There is some small year-on-year decreases, but generally speaking, the trend was upwards. So if I go back, you can see that we had a couple of year-on-years, but generally speaking, we're going upwards. Okay. The country to world correlation shows from -8, which is a high level of negative correlation, up to over 80%, 0.94, 94%, a high level of positive correlation, telling us is that some countries have got trends decreasing over time. That's the ones with negative correlations. Countries are around about zero, so that's neither rising nor falling trends, and some are highly correlated against the average. Okay. Now that said, let's move on to our second polling question. And in this case, second polling question says that with correlation analysis, data in multiple files can be correlated. Data within a single file can be correlated. Non-matching data can be correlated, or graphical results are not possible. If you could please vote now. Okay. That was a high-speed correlation. I will close that, and I will share the results. Correlated, which is exactly what we did. 33% said non-matching data can be correlated. Remember, in order to correlate them, we had to find a match. We matched them based on the year. And we were then able to correlate carbon and carbon within the same year from two different files. Okay. Let me close that. And let's take a look at trend analysis. Now what we're going to do is going back to my country emissions database. If you look at 2004, that's where it stops. We don't have any data for 2005, we don't have any data for 2006. Now we want to do a trend analysis that would allow us to forecast 2005 and 2006. But we need to know, if we're going to do that, how accurate that forecast is going to be. So what we can do is we can take from 1985 through to 2003 and use that data to make a forecast for 2004, and then compare our forecast to the actual for 2004 and see how accurate our forecast is going to be, how reliable our trend analysis is going to be. So the first thing I need to do is go in on my data, and I want to extract from this. This is the data, remember, all the years for all of the countries. So I'm going to go in data and I'm going to do an extract. I'm going to do a direct extraction. The file I'm going to create is going to be called pre-2000. And I'm going to extract all records where I could say where the year is less than 2004, but in this case we're going to say where it's not equal to 2004. And if I give it a big green tick and then say OK, it's going to start all of those, and it's now given me 1985 to 2003. Okay, so I can now go into my analysis and go into my advanced statistics, and now I want to do a trend analysis. And I'm going to do a trend analysis, and I want to trend the carbon emissions, the audit units are going to be by country. I'm going to select all countries. I want to generate forecasts, and I want to create 3 databases: a trend analysis database, a forecast database, and the MAPE database. Okay. Now I'm creating it, and I want to do it from the file pre-2004, and the results are going to be called trend. Okay, so there's my carbon forecast. I'm saying that based on what I have got, it looks like these are the figures. Okay? And that's fine. But now I want to create the file for post-2004. So I'll go back to my country, and again I'm going to my data and do an extract, but this time back to 2004. And the criteria is going to be if the year is equal to 2004. So I've now got the carbon for equal to 2004, and over here my trend analysis is showing me for a forecast based on 2004. So I need to be able to join these two together and include the field the carbon forecast, and then do the comparison. So I'm going to take my 2004 emissions, and I'm going to join that to my trend analysis forecast. So I've taken that as my primary file. I'm going to join the database, 2004, to my secondary database, which is my carbon forecast. Beg your pardon, to my trend analysis, which is my pre-2004, my joined, and I'm sitting with trend analysis, which is called trend analysis. Well, that makes sense. But the one I want is the trend analysis forecast. So I'm going to take my 2004 and I'm going to join the databases based on that to my secondary database, and my secondary database is within my country emissions, and it's within my pre-2004, and it's within the one that's marked trend analysis forecast. I'm going to select and match them. I want all items again in the primary, all records in the primary field, and I'm going to match based on the key of country to country. And when I'm happy with that, so I now have my carbon and my forecast. And we can see that on Albania it's pretty off the mark. On Australia it's pretty close. Australia is pretty close. Bangladesh is pretty close. Belgium it's drifting a little. Bhutan it's drifting a little, etc. So now I want to take my trend analysis to join that file to my trend analysis mean absolute percentage error, which is the file down here. Trend analysis, if I stretch that open a little, you'll see it. Remember I created 3 databases? I've got the trend analysis forecast, and my trend analysis mean absolute percentage error. So I'm going to take my joined file, and I'm going to join that file against a secondary file, and the secondary file is within my country emissions, pre-2004, and this time it's the trend analysis MAPE. And what I'm going to include on that, I'm going to match those. I'm taking all the records in the primary file. The fields I want to select are the carbon slope and the MAPE, and I'm going to join it based on the country in the primary and the country in the secondary. And if I put all of those lot together, it's showing me the forecast, it's showing me the carbon slope, and it's showing me the carbon MAPE. Now, what that's done for me is it's allowed me to create an indicator that exactly for that period where the slope is, whether it's an upward slope or a downward slope, and what my mean average percentage error is. That's what I mean, absolute percentage error is. So based on that, I can see how far off I am. If we look at China, you can see we're way off the mark. Croatia, we're way off the mark. Or are we? There's the actual, and there's the forecast. We're smack on. The carbon slope, and that's a mean average error. Okay, so it's a way of looking at forecasting based on information that we can extract, bringing it down, analyzing it, and forecasting how reliable our trend analysis has been. If I go back on my import assistant, and I'll import to IDEA, and this time what I'm going to do is pick up an Excel spreadsheet again, but what I'm going to look at is a file called unemployed. First row is field names. So what I've now done is I've picked up unemployed by state, by year, from 98 forwards, okay, month by month. You'll see there are 13 periods because it's 4-week periods that are being analyzed. Now what I want to do is take this and do a time series analysis. So again, I can go into my advanced statistical, and this time we'll go to time series analysis. And doing a time series analysis, to do it by time series on people, on states, and I'll include all states. And now it's asking me for my model information. My seasonal length, we know there are 13 periods. We want to create 13 forecasts. Calendar month is going to be a 4-week month. And we're going to again create all 3 days. Time series, forecast, and our mean absolute percentage. This time we'll take the lot. And there's my time series. Okay, for unemployed. If I pick up the MAPE for that, you can see I've got all of these, and if I sort that into descending order, you can see the closest, looking at the MAPE, is Colorado. And if I look at that from results, oops, if I take that, I can sort that into the descending. If I go to my unemployed and look at the results within unemployed, I can go into my time series and I can see it graphically. Now looking at what we're looking at here, the state is Alabama. If I change that one, we know that Colorado came up very high on the MAPE. So we can see where we're going with Colorado, and we can see the actual data compared to the fitted data compared to the forecast. If I go in and examine, for example, Maine, you can see that I'm very much closer when I start looking at that, and I'm sitting with a MAPE of 9.47. If I go back into my MAPEs and I come down to the bottom, and I find that, for example, Nebraska is sitting at 5.63. So if I go back into my unemployed and look at Nebraska, and you can see again the actual data and the fitted data is identical. So we can place a lot of reliance on that forecast that's moving out. Okay, are we happy? I hope. Because it's time for the next. Polling question. Polling question number 3 is looking at MAPE files. And it says a makefile includes the multiple analyzed percentage error, the mean absolute percentage error, the mean absolute percentage evaluation, the mean absolute percentage error on the multiple analyzed, and this is basically to determine whether anyone was listening, because I said it several times. Okay, a couple of seconds more. Okay, and let's close the poll. Okay. Poll results, 25% said that the mean absolute percentage evaluation, 63% the mean absolute percentage error, and 13% the multiply analyzed percentage error. And the answer is it's the mean absolute percentage error. And what it's done is when it's done the analysis, it's calculated the average, the mean, and then it's taking the individual transactions difference between themselves and the mean to calculate the absolute percentage error, and then to calculate the average absolute percentage error. So it's the mean absolute percentage error on the forecast. Okay. So let's take a look then at continuous monitoring. So this is where you can relax. And those of you who've been following along and doing the same thing, you can relax because we're going to be talking some theory on continuous monitoring. Why is it becoming so critical now? Because to a large extent, technological advances has made the sheer volumes of IT processing such that coming along at the end to check what has happened over the past year or 6 months or month or week becomes irrelevant. Coming along at the start to test how the controls are probably to operate is also becoming irrelevant. How effective and efficient the controls are on an ongoing basis, non-stop. We've had all kinds of problems over the last few years, everything from 9/11 through the malfeasance crisis. We're seeing more and more complex business models coming in. We're seeing more and more legislation coming in, and we're seeing all kinds of regulatory requirements which involve organizations being able to spell out on an ongoing basis, here and now, we in compliance? Are we where we need to be regarding all of the legislative requirements? If you take banking alone, banking has got over 140 legislative requirements that have to be complied with. So we've got massive requirements within business, and we need a major competitive development of controls to be matched against those requirements. If we look at the relationship of continuous auditing and monitoring and assurance, looking at that, we've got continuous auditing is primarily dependent on management's role in continuous monitoring of. From a management perspective, they're looking at the comprehensive monitoring of those controls. I've got a question. What is the malfeasance crisis? Malfeasance crisis came about when a whole pile of organizations started to go belly up because of misrule at the top. Okay, board level. I hesitate to use the word corruption, but board level incompetence and corruption, causing crisis out the financial services and right throughout industry. And that led to legislation such as Sarbanes-Oxley being promulgated. Now, Sarbanes-Oxley was designed to prevent malfeasance at board level. The only unfortunate thing about it is the way it's looking at everything except the board. The board is making sure that everything is being checked, but not the board. So there's some real problems with some of the legislation as it's currently being implemented. So looking at what monitoring management is doing and the audit requirement for audit, where management has got very solid, comprehensive monitoring of controls, then audit's efforts can be significantly reduced simply to checking that management is continuing to monitor on an ongoing basis. Where management is doing very little monitoring of controls, audit is now being faced with significantly greater efforts and therefore significantly greater resources which are required. It's an inverse relationship. The greater the role of management, the less of a direct role internal audit requires. So if we're looking to get true continuous assurance, it depends on effective monitoring by management of internal control, and audit's role then becomes independent assessment of management's role and the effectiveness of the monitoring. There's a danger, and there has always been a danger with audit, that in conducting continuous auditing, you become the control. Audit is designed or intended to audit management's effectiveness in implementing control, not to be the control instead. Continuous auditing is ours. It's owned and performed by internal audit, and it's primarily detective in nature. Continuous auditing says we are looking to ensure that we are within acceptable tolerances. The error rates are not exceeding 5%. The error rates are staying below the level of tolerance of management. Okay? And we are then activities. We're not responsible for doing it. We're responsible for evaluating how it's being done. Continuous monitoring of and is owned and performed by management. And continuous monitoring can take the form of preventative, detective, and/or corrective. And continuous monitoring, the way it's implemented, qualifies itself as an internal control, where continuous auditing must not become an internal control. We're auditing how management is implementing continuous monitoring. Benefits: if it works and it works well, we get immediate, not to audit but to management of problems occurring and the capability of making corrections. Now, the reason that sounds vague is because it gives them the key to making timely corrections. It gives immediate notification to management, but it doesn't necessarily force them to do anything with it. We can get fraud reduction and improved risk management, and we can get extensibility across multiple IT systems, which means that our monitoring can then be independent from our operative management. As far as fraud prevention is concerned and compliance, The key drivers looks at the laws and regulations. There's a direct profit and loss impact if you can prevent fraud losses. There's also an indirect profit and loss impact if you can improve your business reputation or at least maintain it and retain your clients and acquire new clients. Now, when you start talking fraud, to detect fraudulent, unauthorized or money laundering activities, those operational systems need to be monitored on an ongoing basis. Know your customer is great to prevent money laundering, but when your customer, your known customer, starts doing things that they're not supposed to do, it's too late to find out way later. You need to know immediately. So they need to be monitored on an ongoing basis, with all systems producing activity and transaction logs, with the format depending on the nature of the system. And if you do that, you can go across all of your systems using some form of centralized monitoring dashboard, so you can see all the business transactions and all of the IT systems, and you can see a rating for how they're all performing against predetermined tolerances, whether it's an error rate of 5% or less, or whatever the tolerance is that has been preset. Now that audit trail becomes imperative, and to get it right, you've got to get right down to the finest level of granularity, okay, as close to real time as you can get. So you're talking individual transaction by individual transaction. You're talking about having the software capability to drill down, right down to the lowest level where required. You won't necessarily monitor everything at granular level, but if you see that those error rates are rising, you need to be able to drill down and get down to that level, which means that the source data that you're dealing with has to be high quality source data, and the data level has to be assured. This then becomes your proof, your forensic proof for internal and public proceedings, to show that you can drill down to determine whether fraud has occurred, fraud has not occurred, whether the laws and regulations are being complied with, or whether they're not being complied with. And that means you've got to get down to transaction level. Okay. Now, in many modern systems, the transactions exist and they're gone. They are not retained as a transaction trail because of the volume of data. Nevertheless, from an audit perspective, we need that granularity of the transaction level audit trail. Continuous from all auditors understand and implement IT at an in-depth level. So you need to understand what's going on in the IT divisions of the company, within the systems that are being implemented, within the control environments governing those systems, within the individual controls operating within those systems, and within the monitoring of those controls. And at the same time, from a continuous auditing perspective, accumulate evidence to communicate to management the current status of their risk control objectives. Okay, now that sounds very like continuous monitoring. Okay, be careful. We're talking about providing evidence of the current status of management's risk control objectives. We are not the control, we are auditing the controls. So continuous auditing itself is therefore a type of auditing that produces audit results simultaneously with the occurrence of the relevant event, or at least with a short period of time after the occurrence of relevant events. Okay, let me give you an example using fraud again as an example. There are two basic kinds of fraud. There's the hit them once, hit them big, and jump the country type of fraud. Okay, now detective controls that tell you that $100 million has just been transferred out of the country is too late. Okay. On the other hand, you get the other form of fraud which says take a little, take it frequently, and bleed them dry over a long period of time. With that kind of fraud, we are needing to monitor trends and do our trend analysis over extended periods, because you're not going to pick it up in the very short term. So rather than look at it from a continuous auditing perspective, we're more accurate to look at it as an instantaneous audit. As soon as something starts to deviate from the norm, whether it's a big one once or whether it's a trend that's starting to accumulate, we need to know immediately. Not necessarily frequently, but immediately. Okay. Without continuous monitoring, if you don't have that continuous monitoring in place, then for audit to be able to audit, management has to maintain an activity audit trail for us to look at. They have to enforce access control standards. They've got to do the standard internal controls that you would expect, banning standardized administrative passwords, enforcing change management, facilitating independent inspection of infrastructure management records. At the end of the day, the auditors have to know what's going on within your own environment. So you need to keep current. Not just current with the latest trends in auditing and current with the latest technology that's available out there or the latest tools which are available, but you need to stay current with what your organization is doing right now. Which brings us to polling question number 4. Looking at Jim.
I'm here.
Sorry, I thought you had a question.
Nope.
Okay. Let me launch the polling question number 4. True continuous assurance is what? Dependent on internal audit's effective monitoring of internal controls, primarily detective in nature, primarily preventative in nature, or dependent on management's effective monitoring of internal controls. What is true continuous assurance? Okay. Let me close that poll and share the results. We've got 10% saying it's dependent on internal audit for effective monitoring. It's supposed to be management who are monitoring. We are taking monitoring. Again, if it was continuous auditing, but if it's continuous assurance, that's management's role, and that's preventative, detective, and corrective. But at the end of the day, for continuous assurance, management has effective monitoring of internal controls themselves. Okay. Moving on. Meeting the needs. Today, we have some major challenges to audit. The regulations are coming in thick and fast. Companies are looking to audit to, number one, know what those legislative requirements are, and number two, implement them. And it's not our job to implement them, but it is our job to assist management to implement them. So our regulatory compliance and controls, huge challenge. We are needing to add value. Management is looking to us to assist in ensuring regulatory compliance and ensuring risk evaluation, ensuring risk control. But at the same time, we're trying to maintain our independence. There is a huge shortfall in audit right now in skilled resources using the appropriate technology solutions. And we need to determine what are the appropriate technology solutions. It's not a question of let's go buy a package, now let's see what we can do with it. It's a question of determining what is our need, what is the choice that we would be able to make, what software would be appropriate, if software is an appropriate solution, and then implementing those effectively. There's the need for timely ongoing assurance over risk management and control systems. Management's looking for it. In fact, management is demanding it. And the role of continuous auditing is providing us with more frequent, more timely analyses so that we can provide more effective recommendations to management regarding their control deficiencies and their monitoring and control of risk on an ongoing basis. Management's role, audit's role, as I said at the start, the role of continuous auditing depends on management's role in continuous monitoring. The greater the role of management, the less of a direct role that we have as audit. And conversely, the less management's role is implemented in continuous monitoring, the more they're looking to us to do a direct role as internal audit. And that's a problem. Continuous monitoring and auditing, we need to be able to look and determine efficiently and cost effectively sustain control assessment and testing efforts coming the control systems, to know the source of information within your systems, to know the level of risk that management has said they are prepared to accept, to know how management is trying to control that. And we may have been the people who recommended some of those controls, to know how management is monitoring their ongoing effectiveness, and to know how to test whether that is working or not. Now that's a huge problem. When you start combining that with such eventualities as cloud computing, where you don't necessarily have full control over all of the information flow within the organization, then continuous monitoring from a management perspective becomes a nightmare, and continuous auditing is equally difficult. So we need to determine within our own environments, within our own organizations, how will you know as an auditor, how will management know as a manager on a timely basis when control deficiencies occur? And how are you going to quantify the impact of those control deficiencies? We've looked at some with correlation analysis, we've looked at some with trend analysis. We need to be able to monitor those on an ongoing basis, and we'll look on the next webinar at how we can set up scripts that will run for us and do this kind of analysis on an ongoing basis without us continually having to do it, that will immediately flag red flags when error levels are breached. How do we improve our effectiveness of our controls, and how to gain assurance over ongoing effectiveness of control? It's not our job to make sure that they're effective, that's management's job, but it is our job to provide management with assurance of fact working. Problems right now in the traditional approach, it's retrospective. The analysis typically occurs long after the transaction has taken place, and it's too late for any action. Now that happens even if you're doing an audit at end of day. At the end of a day, a bank can have processed 1.5 million ATM transactions. It's a bit late at the end of the day to realize that the PIN number validation has been switched off, or that controls that you were relying on are no longer effective. and haven't been since 10 o'clock this morning. So we need to work real time, not retrospective. We've got a lack of timely visibility into control risks and deficiencies because the systems have not been set up that way. Generally speaking, IT systems have been designed to work and to make sure that they work. They have not been designed to monitor their controls on an ongoing basis. It's taken long enough for us to get them to build the controls in the first place, let alone monitor them. The alternative is to independently test all transactions for compliance with controls at or soon after the point at which they occur. Now, you can't do that manually. You're going to have to use the computer to audit the computer, and management is going to have to use the computer to manage the computer. And that's a problem because many managers do not understand the IT world sufficiently to recognize when the controls that they think they are relying on are in fact becoming ineffective. When, for example, accuracy, completeness, validity, all of the control objectives, they haven't changed because of the nature of the business. They have changed in the way that we are achieving those control objectives or not achieving those control objectives. So we've still achieved the same things, but in a different environment. And therefore the way that we do it is going to have to be different. Continuous auditing, we can for continuous control assessment, so that we can look at our controls. We've audited them when the systems were first designed, first implemented. We've audited change control to make sure that the controls don't change. But we need a way of monitoring real-time control deficiencies, identification of fraud, waste and abuse as it happens. Ideally before it happens. We can identify fraud opportunities, waste opportunities, abuse opportunities. We can roll this thing out to look at continuous risk assessment. Now, you can't do continuous risk assessment unless management has already decided what their acceptable risk levels are. All we can do is say we are continuing to do what we used to do, but we don't know if that's successful. So the first part of continuous risk assessment is management has to decide what risks are they prepared, and therefore they're prepared to spend resources on to control. So we need examination of consistency of the business processes, the control processes, and the IT processes. That means that we need to develop an enterprise audit plan. No longer do IT auditing methods. We've got to be able to run across the board and look at when statistical interdependent. We have to be able to support individual audits at the same time provide capability. We need to audit, we need to know for each business process area. And that's a problem because most tertiary education that management has gone through did not talk about control objectives. In many cases, it didn't even talk. We need to get the message across of what a control objective is. If the business objective of your procurement division is to buy things, then the control objectives are to make sure that you buy the right things at the right price from the right supplier at the right time, in the right quality and the right quantity for delivery to the right place. All of those are control objectives. And the opposite side of that is that we will buy at the wrong price from the wrong place, from the wrong supplier in an unauthorized manner. So the opposite side of the coin from the risk is our control objective, and the opposite side of the control objective is the risk. And management has to be able to clarify and identify their control objectives before they can establish how they are going to control to reach those control objectives. We can then establish tests using our transactional data. We can validate the achievement of each of those control objectives. We need to be able to establish tests that will identify any suspect transactions. And that means that we can use different types of transactional profiling techniques, and we'll then be monitoring against those profiles. And that means that we can then, using our scripts, we can subject all transactions to a test bed of interrogations on an ongoing, regular, timely basis. The objective being to highlight instantly all transactions that fail the metrics, notify the appropriate personnel so that they can sort it out. There's a danger. If you set the metrics too tight, then if you're processing 1 million transactions, 750,000 of them are going to say, this could be wrong. Check it. And the errors disappear in the sheer bulk. So the metrics have got to be tight enough to be realistic and loose enough to be practical, to allow the people to identify discrepancies, correct the transactions, and if the transaction discrepancy resulted because of a failure of internal control, to fix the control problem. If it resulted from a lack of internal control, to introduce the appropriate controls without having to wait till the end of the year when the auditors come and tell them what to do. Required of continuous auditing, we need to have the authority, we need to have the skills to access and normalize disparate data from right across the whole organization. We need to be able to put together a test bed to effectively address each of those control objectives across the enterprise. And then make sure that those tests are as flexible as they need to be. But I'm sure of is, although the objectives be the same, the true opportunity to change as new staff come in, uses of information coming, testing of data and reporting of results, real time. But at the same time, we've got to be able to take those huge volumes of data and do all of this with no negative impact on operational system performance. If you're processing 20 transactions with an average value of 100 million, it's worth spending 1 minute per transaction to make sure you got it right. If you're processing 20 million transactions, each one worth 100, it's not worth spending half a second. Therefore, you've got to focus on the operational system performance. We need to provide variable parameters for our tests and at the same time provide alert notifications. I'm getting a question coming in. No, I'm not. Sorry. So, large volume of transactions, no negative impact, with variable parameters for our tests so that we can fluctuate it depending on the movements in the business, allowing for notification of alerts while maintaining security and integrity of our tests and our results themselves. And that means that life over the next 10, 15 years is going to be quite a challenge for auditors. We're going to have to get the appropriate data access, define with management the appropriate measurement metrics, set up the appropriate thresholds, develop an appropriate metrics to prioritize exceptions, and do it all without actually causing any damage to the performance of the systems. And that brings us to polling question number 5, which looks at what continuous auditing can be used to do. Continuous auditing can be used to or for examination of the consistency of processes, retrospective examination of evidence, providing less frequent assessments to better manage controls, or determining the impact of control deficiencies. And we're all voting now. Right now, we'll close the poll in a couple of minutes. Okay. 100% the auditing can be used for examination of the consistency. It's not whether the evidence is good or whether the evidence is bad, it's whether the controls and the processes are happening on an ongoing, consistent basis. Implementing continuous assessment. How do we do it? We need to establish upfront what are the audit objectives and requirements. Get the executive level support. This is not going to be a cheap exercise. This is going to be expensive, it's going to take a lot of time, it's going to take a lot of effort, a lot of skills. You need that executive level support. If you don't get it, then it really doesn't matter what you're doing. Your results may be ignored. We need to ascertain the degree to which management is performing that monitoring role and whether they understand the need for them to perform that role. Then we can select the appropriate technological solutions, identify the information sources, and get the access rights that we require. And again, if you're in a cloud environment, that might not be easy. We need to understand the business processes themselves and the key controls and risks, and we need to build our own audit skill set. The days when you could look at a computer and say, oh, it's a computer, let's call in the IT auditors, are gone. Every auditor has to be able to handle this in the stride. We need to be able to manage, and we need to be able to report our results. Timing, there's a lot of work going to be required up front. There's a lot of work required to monitor any changes within systems. And that includes changes within the software, the hardware, the networking, the people. We're going to have to move towards alarm-based intervention, and that means that we need to sit down with management and help them identify the appropriate metrics. We need automated interim work, continuous confirmation, with detailed testing only when exceptions are noted. If we look at where continuous monitoring has come from, we started off at the bottom with manual processing, full user intervention, a lot of retrospective testing, a lot of sampling, looking at what happened over the last year. We're now seeing some user intervention required with individual macros, periodic testing of selected areas, and that's where most organizations are sitting at the moment. Audit goes in every 3 months into high-risk areas, or once a month into high-risk areas. But we're only doing it once a month. We're starting to see some menu-based applications with limited user intervention required, so we're getting regular testing of identified risk areas. But again, regular, not necessarily real time. Where we're heading for and where the big savings are capable of being made is in the automated testing and continuous monitoring, where there is no human intervention required. Frequent testing for leading indicators of problems, and the human being only gets involved when problems have been identified. Now that looks easy, it sounds easy, it's a nice diagram. There are obstacles. It's not that easy, unfortunately. We need to be able to get hold of the data easily on a systematic basis. That's not easy. We need to standardize the analysis process by identifying key risk areas and the leading indicators. And that means getting management to sit down and do that. Identifying a champion, a product champion, to spearhead the creation of custom analysis routines and allocating the time to complete the work. I've been talking in terms of how difficult it is to get management to do it. It's not always that easy to get audit management to go ahead with this. So we need a product champion within audit to spearhead that. Avoiding the use of multiple applications to produce the desired output, and it does happen. I see auditors who use IDEA and ACL and Excel, and they're hitting the same data with multiple tests in different environments, coming up with different results. Then they're trying to correlate those. We need to move to proactive monitoring from the historic focus to periodic retrospective testing. Get out of that mindset. Which brings us to our last polling question. You'll be glad to know. Our last polling question is looking at continuous auditing. Continuous auditing requires that our control objectives are predefined, thresholds exist for deviation rates, exception reporting is already in place, or disparate data from across the enterprise is accessible. What is required for continuous auditing? Auditing, not monitoring. I'll close the poll. What we're seeing is 50% saying that control objectives predefined, 25% that exception reporting is already in, and 25% that disparate data from across the enterprise is accessible. Okay, remember what you're doing with continuous auditing. For continuous monitoring, yes, the control objectives have to be predefined. For continuous auditing, the auditor has to be able to get that data wherever it is within the organization. So we're really looking at disparate data has to be accessible. If you're going to do this on an ongoing basis, you're going to have to implement repetitive scripts. There's an example of an idea script where it's going to go and it's going to loop and it's looking for certain amounts, it's looking for an amount greater than 20,000, and it will then execute certain tasks and certain alerts. That we'll be looking at on in the next mental information you get. Is what is the loading day, sample letters, etc. across the organization. Ladies and gentlemen, are there any questions?
I don't see any additional questions that have come in, Richard.
That means I've either put everyone to sleep or everyone is now totally convinced, or everyone wants to go away and think about it and then hit me all the questions by email, which is fair enough, no problem. Our next webinar will be following on from this on the 30th of October, looking at basic script writing idea to set up the scripts that can be used for continuous monitoring.
And we look
And
forward.
that brings me to the end.
Very good, Richard. Well, thank you everybody for joining us today and for your questions, those of you that asked questions. And thank you, Richard, for covering today's webinar on continuous monitoring using advanced statistical analysis. And as Richard mentioned, our next, and I believe, is this our last webinar in the series? I believe it's getting close to the end, but it's going to be basic script writing. And script writing, is, of course, is one area that meant...
Two more to come.
Two more, okay.
Idea 9, Idea 10.
Okay. The script writing webinar is one that you will find very useful. Script writing does automate a lot of the routines and is a fast way to get in there and do your testing, so we look forward to that. Again, the purpose of our Training Without Travel webinars is to provide you with high-quality, low-cost online alternative training solutions covering timely topics with value-added resources and tools that you can use in your job. We bring the world's best subject matter experts directly to your desktop with timely information. If you paid for today's webinar, you will be receiving your CPE certificate as well as a link to the recording. For those of you that attended today and did not pay, you do have the opportunity to pay, receive CPE as well as links to the recording and the supplemental materials. So with that, if there are no additional questions, I'd like to wish everybody a great day, and thanks again, Richard, for putting on this webinar.
Okay, there's one question on MAPE that's not been answered yet to the question of satisfaction. I'll go through it and I'll come back to you by email.
Okay.
The next webinar, as I said, is on scripts. And final one, webinar 10, is on using the advanced @ functions.
Very good. Wonderful. Okay. Well, thank you again, everybody, for joining us today, and have a great day.
Thank you.